Hello everyone. Today we are going to take the third numerical on the module for the electrical circuit fundamentals for gate. Before this, in the two videos, we have seen when the voltage and current waveforms are applied to the capacitor, what are the outputs at a particular time intervals. Here, the question is in the form of the sine wave. The question is that the current through the 100 microfarad capacitor is 50 sine 120 pi t milliampere. Take note of it very carefully. The value is in milliampere. Calculate the voltage at a time interval of 1 millisecond and 5 milliseconds. Take V0 of t is equal to 0. First we will see what do you mean by V0 of 0 equals to 0. So this means that capacitor is initially uncharged. This is a very important condition to solve this type of numerical. Or we can say that initial capacitor voltage is 0. This is another concept. They both means the same thing. In the further videos, we will see how the capacitor is called as a memory element, how we can define V is equal to 0 minus value, V is equal to 0 plus value, and V is equal to 0 value, and how these values are related to only capacitor, not the inductor. Why capacitor is called as the memory element, inductor is not called as the memory element. We will see all this concept in the further videos. This is the basic understanding for it. For now, you should know that V of 0 means capacitor is initially uncharged or discharged or initial voltage is 0. Then C equals to 100 into 10 to the minus 6 farad. So C will be 10 to the minus 4 farad. Vc of t will become 1 by C 0 to t I of t dt. We have taken the value from 0 to t because the value at the instant of 0 was 0. The value of the voltage at the 0 instant was 0. We will get more conceptual understanding if we solve the numerical further. Okay. So the current flowing through the capacitor is given by I of t equals to 50 sine of 120 pi t. Okay. So Vc of t will become 1 by C 0 to t I of t. Basically we have to put the value of current in this. But solution is a little bit tricky. So we will solve the complete numerical. Okay. Now first point. Vc of t is equal to 0 to t 50 sine of 120 pi t dt. Okay. Vc of t equals to 1 by C into 50 into minus cos of 120 pi t upon 120 pi 0 to t. 1 by C into 50 into minus cos of 120 pi t upon 120 pi. We will take the first condition of 1 milliseconds. This is the first condition. We'll solve further. Vc of t equals to 1 by C into 120 pi 50 here minus cos of 120 pi t 0 to 1 milliseconds. 50 upon capacitor value of 10 to the power minus 4 into 120 into pi minus cos of 120 pi time is 1 millisecond plus cos of 0 is 1. We have put the upper limit and lower limit here, nothing new. If you calculate this, it comes out to be 1326 and minus cos of 120 pi into 10 minus 3, this will become cos of 0.12 pi plus 1. Okay, so this comes out to be 0.070 and this value comes out to be 93.11 value. The value of the voltage will be in the millivolt because the current was in the milliampere as we have seen in the question. This complete equation is in milliampere. So finally, the value will be in millivolt. We have to multiply it with the factor of 10 to the power minus 3. This was the first part. 93.11 millivolt is the voltage at the instant of 1 millisecond. Now the second part was of 5 millisecond. Okay, so we will take the same equation here. The equation till here the equation will be same, minus cos of 120 pi t 0 to 5 millisecond. This is the second condition. So this value comes out to be 1326. This comes out to be minus cos of 120 pi into 5 into 10 raised to the power minus 3 plus 1 into 10 raised to the power minus 3 because of the milliampere factor. Okay, please calculate the value, and after calculation we will get the value of the 1735 into 10 raised to the power minus 3, which can be written as 1.735 volts. So this is the value at the time interval of t is equal to 5 milliseconds. This question will give you the conceptual understanding of how to solve the numerical when the current is in the form of the sine wave. We have to solve this question by using the integration, and we have to be very careful while putting the values of the upper and lower limit, and we have to see if the values are in seconds or in milliseconds. In further videos we will see the further conceptual understanding of capacitor past value, capacitor present value, and V is equal to 0, V is equal to 0 minus. Basically we are going to solve the numerical for the initially charged capacitor. Whatever the feedback you have about the 3 videos, you can put it in the comment section. You can also like the videos. You can also suggest something that will increase the quality of the video. Thank you.